Here are the notes for section 1-2, solving multi-step equations. We have a couple key vocabulary terms that we need to discuss. Inverse operations, which came up last section, are two operations that undo each other. For instance, multiplication and division are inverse operations. Addition and subtraction. If you have x squared, the opposite, or the inverse operation, would be the square root of x. So those are a few examples. Mean. The mean is also another word for average. So if we take a data set, it's, let's do 4, 3, 2, and 3. It's a pretty simple data set. If you take the sum of the numerical data set by adding them all up and then dividing by the number of data values, that's your mean. So if we added 4 plus 3 plus 2 plus 3 and divided by the number of data values, which is 4, you would end up with 12 over 4, which equals 3 as your mean. All right, let's talk about solving multi-step equations. Example 1. You have 2.5x minus 13 is equal to 2. So in order to solve for a variable, we have to get the variable x alone. So everything on the left side of the equation with x needs to go except for x. And the way we do that is we use the order of operations. Please excuse my dear Aunt Sally backwards. So is anything being added or subtracted to x? And the answer is yes. We have this 13 that's being subtracted. So the inverse operation would be addition. But if we add 13 to one side, we'll have to add 13 to the other side. So that cancels the 13s. On the left side, we have 2.5x equals 15. Now, 2.5 is being multiplied to x. The inverse operation is division. So we divide both sides by 2.5. That goes away. And if you had to do this without a calculator, 15 divided by 2.5, well, we would move the decimal for 2.5 over. You'd have to do the same thing. If you moved over once for 2.5, you'd have to do once for 15. So you have 150 divided by 25 now, and that is 6. So x equals 6. And I would like you to check your answer. That's plugging 6 back into the problem. So to check it, you can just say 2.5. We'll do it in this box. So it could be 2.5 times, we got the answer of 6, so we'll substitute that for 6, minus 13. So 2.5 times 6 is 15. 15 subtract 13 and you end up with 2, which is what the original equation had. It's right here, 2. Okay, example 2. For example 2, we're going to have to combine some like terms. So we have negative 12 equals 9x minus 6x plus 15. Combining like terms means you're going to combine terms that have the same variable attached to them or a constant, but they must be on the same side of the equal sign, the equation. So on the left side, negative 12 is by itself. It can't combine with anything. There's no other term. On the right side of the equation, we have 9x, take away 6x. So those are like terms. All right, 9x take away 6x would be 3x plus 15. And that's going to equal negative 12. Now it's very similar to the last example. We need to get x alone. So in order to get x alone, first of all, is there anything being added or subtracted to it? And the answer is yes. 15 is being added. The inverse operation is subtraction. Whatever you do to one side, you must do to the other side of the equal sign. So we get negative 12 minus 15 is negative 27 equals 3x. I'm going to move it over here. So now x is being multiplied to 3, so the inverse operation would be division. So we would divide both sides by 3 to get rid of that 3. And you would get an answer of x is equal to negative 9. To check it, you would plug it back into the equation. Here's the check for this problem. For the next two problems, they're on your own, so I want you to pause the video, work them out, and then when you're done, unpause the video and check your work against mine. So for letter C, you should have gotten n equals -3, and for letter D, you should have gotten C is equal to -20. One thing I would like to point out in letter D is when you set up the equation, we're going to add 11, great. So then you're left with -10 is equal to 1/2 C. To get rid of a fraction, the inverse operation is to multiply by the reciprocal. So 1/2 has a reciprocal of 2 over 1. Just multiply by 2. The 2's cancel, the 1's cancel. Whatever you do to the right side, you have to do to the left. So -10 multiplied to 2 is -20. Okay, next example. Oops, we're over here. All right, we're going to show you two ways to do one problem. So I'm going to rewrite the problem. We have 2 multiplied to 1 minus x in parentheses plus 3 is equal to -8. So we're still going to use the properties of doing the opposite of the order of operation. So if we do that, on the left side, I'm going to look for anything being added or subtracted to x. Since x is in the parentheses, according to the order of operation, we can deal with parentheses last. So what's being added or subtracted to the x would be the 3 outside the parentheses. So I'm going to subtract 3 from both sides, and then I will eliminate the 3 on the left side. We're left with 2 times parentheses 1 minus x is equal to -11. And now we look for anything being multiplied or divided to x, and we have the 2 on the outside here, so I'm going to divide both sides by 2. That eliminates the 2 on the left side. I'm left with 1 minus x. I'm no longer writing the parentheses because the parentheses are gone, equals -11 halves. And then finally, there's 2 more steps actually. We need to get rid of the 1. So it's a positive 1, so we will subtract 1 from both sides. And this sometimes students forget, they just bring down an x, but that's not all that's left. If I were to cancel that out, you actually have your negative sign in front left. So -11 equals, now we have a fraction and then an integer. So to do this, we can think of -11 halves as -5.5. And if we take -5.5 and subtract 1, we're left with -6.5. And finally, we need to divide by -1, and anything divided by 1 just means you change the sign. So you get x is equal to 6.5, a positive 6.5. Another way you could think of this right here, -11 halves divided by, or take away 1, you could think of it, and I'll do it in a different color so you can see my work. You could make a common denominator. So you can go 11 halves minus, instead of writing 1, you can do 2 halves, because 2 over 2 is 1. So then you would have -13 halves, which is the same as the -6.5 that you have here. Either way. Okay, we're going to do this problem and use a different method. So here we go. We have 2 times 1 minus x, close the parentheses, plus 3 is equal to -8. This time, instead of subtracting the 3 and leaving the parentheses in place, we're going to distribute this 2 first. So we're going to distribute the 2 to the 1 and the -x. So 2 times 1 is 2. 2 times -x is -2x. Then we're going to add the 3 equals -8. Now we're going to combine the like terms on the left side. We have 2 and 3. 2 plus 3 is 5, so we have 5 minus 2x is equal to -8. Now we're going to solve and get x alone. So in order to do that, we're going to get rid of this 5 first by subtracting it. 5 is gone. We have -2x is equal to -13. And then to get x alone, it's being multiplied to -2. The inverse operation is division. We'll divide by -2. And x would equal a negative over a negative in division turns into positive. So we have 13/2, which is also 6½. Either method works. Sometimes one is more preferred than the other. So for instance, I'm going to use both methods in this situation for f and g. So when I look at f, I'm going to use the first method that I taught you, and I'm going to subtract 6 first. So then I have 3 times x plus 1 is equal to -15. And then I'm going to divide by 3, and I have x plus 1 is equal to -5. And the last step is to get rid of the 1. The inverse operation would be to subtract it from both sides. So we have x is equal to -6. And when you plug that in, you have -6 plus 1, that's -5. -5 times 3, that's -15. -15 added to 6 is a +9. So I did check my answer. I would like you to write it out if it says to check it and get used to doing that. On the next problem, letter G, I'm going to do the second method that we talked about. I'm going to make it a little bit bigger and zoom in. We're going to distribute first. So I'll distribute the 5 to the 3 and the -x. And I chose to distribute because there's 2 distribution problems here. I'm going to distribute the 2 to the next parentheses with 3 minus x. So back to the beginning, 5 times 3 is 15, 5 times -x is -5x, plus 2 times 3, which is +6, and then 2 times -x is -2x equals 14. We have a couple things to combine here. On the left side, we have 15 and 6. 15 plus 6 is 21. We have -5x and -2x. Combine those, you have -7x is equal to 14. Now to get x alone, I'm going to get rid of this 21, so subtract 21 from both sides. Make sure you bring down -7x is equal to -7. 14 minus 21 is -7. To get x alone, we divide by -7 on both sides, and x is equal to +1. In order to check that 1 is correct, let's plug it in a little bit. So 3 minus 1, when I plug the 1 in right here, 3 minus 1 gives us 2. So we'll have 5 times 2 plus, when we plug in the 1 here, 3 minus 1 again is 2, so we end up with 2 times 2. Well, 5 times 2 is 10, plus 2 times 2 is 4. Add those together, we get 14, which is what we had on the right side of the original problem. So we did get the right answer. Last problem. We have to find the missing number for Friday. So let's read the problem. It says, use the table to find the number of miles X you need to bike on Friday so that the mean, or the average number of miles biked per day is 5. Okay, as we said, when you have the mean, the average, you're going to add up all your data values. So we're going to add up 3½ plus 5½ plus 0 plus 5. And even though we don't know the value for Friday, we're still going to add x into our data values. We're going to take all of that and divide by the number of values there are. So we have 5 values. We'll divide by 5. And it said we want the average to equal 5. So on the right side, we'll make that equal to 5. A couple things you can do here. Anytime you have a bunch of stuff on the top of a fraction in the numerator, or it sticks together. So it's as if there is a parentheses. You don't have to write the parentheses, but it acts that way. So there's a couple ways we can do this. We could combine all of these like terms and get it to add to x, which is what I'm going to do, so we have less to write. So 3½ 3.5 plus 5.5, that gives us 9. 9 plus 0 is 9, plus 5 is 14. So we're going to write 14 plus x divided by 5 is equal to 5. Now, like I said, we don't have to put the parentheses. If you like to visually see them, go for it. We need to get x alone. So what's happening is x is being added to 14. That's going to stick together until the last step, and then divided by 5. So the inverse operation of division would be multiplication. So I'm going to multiply both sides by 5 so I can cancel it out on the left side. So now I have 14 plus x is equal to 25. And finally, since 14 plus x is the last thing, we're going to subtract 14 from both sides, and x is going to equal 11. So your final answer is 11 miles.